Okay, so, what I have here, I've got a cup full of BBs. See? Okay, and I've got a little BB here. That's a little Bobby, the BB. They all have names. Now, if I divide, I'm doing this publicly, yes. I'm going to post it. Okay, if I divide the weight of all these BBs by the weight of little Bobby BB, what do I get? I'm going to get a big number, and what is that big number? It's more or less the number of BBs in here. Okay? Now, if little Bobby's a little light, then it'd be a little bigger than this number, but not much, because these things are manufactured pretty uniformly. Okay? And if little Bobby's had a little too much Thanksgiving dinner or whatever, then the number might be a little lower, right? Okay? So we'll put Bobby back in right next to little Susie. Okay, so the point is, if we divide a number that isn't small by a number that is tiny, we get something big, right? So when we divide -10 by this number that's very small, we get a number that's very big. Now, it might be a very big positive number or a very big negative number. It could be either, because of course our small number could be positive or negative, right? Okay? Okay, not small divided by very small, might be hard to read, is very big. Maybe positive or negative. Okay? That makes sense? Because if you understand that, then you can understand the graphs of rational functions much better. Okay? Okay, so what's that do to this graph? That means as x gets close to 1, the value of this thing explodes on us. Because there's no limit to how small the number can be as you approach 1, right? If x gets closer and closer to 1, f of x gets bigger and bigger without any bound. There's no bound on how small x minus 1 can be, right? It can be as small can be. So this quotient can be as big can be. And maybe positive, maybe negative, but big. Okay? What's that mean? It means that the graph if we approach from the left, it either goes up really fast, approaching this thing is an asymptote. Asymptotes aren't things that happen because you memorize that they happen under certain circumstances. They happen generally from division by very small numbers. And if you understand that, then you can figure them out. Okay? Now, if you're preparing people to pass an SOL, you just teach them to memorize. When this happens, you got an asymptote. No reason. You're not producing thinkers. You're not producing people who can analyze things. You're producing people who can circle the right number or the right letter on a standardized test. Okay, and you've had too much of that, and we're trying to, part of the reason we're talking about these things is to try to move you on a little bit, right? Okay, so whether you appreciate it or not, and I think most of you do, at least nobody's thrown things at me yet. Okay? And I would understand if you did. I've got pretty good reflexes. I've got good hands. Don't be shooting things at me. A bullet that comes out over 1,000 feet per second, I can't slap it away. Okay. Okay. Well. You don't know whether this thing's going to go up this way or down this way, but you know it's going to do one of them, right? Well, actually, from what we have on the board, you do know which way it's going to go. Which way is it going to go? what do I have on the board that, right here, that might give us a hint as to whether it does this
The
or
positive and negative
this?
signs?
Huh?
The positive and negative signs?
Yeah, it's positive in this whole interval, right? Ain't no way it's going to do this, because that would make it negative, right? Okay? So it has to do this. It's positive, so it has to approach the vertical line x equals 1 as an asymptote. And from this side, it's going to go up. Okay? What about from this side? Yeah. I wasn't sure whether you were dismissing me or saying it goes down. Again, either would be justified, so it's fine. Okay, so here it has to go down, right? Okay, so now draw me the rest of the graph.